Good morning, my dear student and respected teacher. Because it is the need of most of the teacher as they had somewhat least knowledge of logic gates. So today we will discuss which type of examples, which type of numericals will be asked in what previous years of Neet Jee or CET examination in different states. So as you know very well that only there are three basic logic gates are there, and what are they? It is a NOT gate, AND gate, OR gate. Their symbols are shown like this, and remember, as far as the logic gates are concerned, their output is expressed with the help of a Boolean equation. What is the Boolean equation for NOT gate? Y equals complement of A. What is the Boolean equation for AND gate? Y equals A dot B, and the Boolean expression for OR gate is Y equals to A plus B. Similarly, Boolean expression for XOR gate is Y equal to A XOR B. When plus sign is written within a circle, you read it as A XOR B. Then A dot B whole complement, it is Boolean equation for NAND gate, and A plus B whole complement, it is Boolean equation for NOR gate. Here NAND gate and NOR gate, by using these gate, as it is possible to construct all the basic logic operations, hence they are called as a universal building block. Remember, whenever we have to solve the example based on a logic gate, you simply remember the condition of input for which output of that corresponding gate is 1. Output of corresponding gate is 1. See here, NOT gate is that gate whose output is 1 when its input is 0, because output is what? Y equals to complement of A. Complement of 0 is 1, complement of 1 is 0. AND gate, see here, output of AND gate is 1 only when both the inputs are 1, because logical ANDing A dot B, this logical ANDing is equivalent to multiplication, and we know 1 into 1 is 1. Whereas what are the four possible combinations? 0 0 0 1 1 0 1 1. When a logic gate is having two input, remember every logic gate has one and only one output, but it may have one input, two input, three input, many input. So AND gate is that logic gate whose output is 1 when both of its inputs are 1. OR gate is that logic gate whose output is 1. We will focus, we will concentrate only on those conditions of input for which output of that particular gate is 1. So output of OR gate is 1 when at least one of its input is 1. Look at this, when at least one of its input is what? 1. Then only output of OR gate is what? 1. If more than one inputs are 1, okay, again output is what? 1. Now exclusive OR gate, see here, as far as this OR gate is concerned, 0 1, for the input 0 1, output is 1, 1 0, output is 1, but for when input are 1 and 1, then also output is what? 1. It means such type of ORing, it is called as inclusive ORing. In why here we call it as inclusive? Because output of this OR gate is 1 even when both the inputs are 1. Now in exclusive ORing, when both the inputs are 1, then output is 0. Means XOR gate is that gate whose output is 1 only when inputs are unequal, means it is equality detector gate. XOR gate is also called as what? Equality detector gate. When both the inputs are 0 0 or 1 1, output of XOR gate is 0. Means it will detect that both the inputs are equal. If the two inputs are unequal, then the output of XOR gate is what? 1. Similarly, as far as the NAND gate is concerned, output of NAND gate is 1 provided what? At least one of the input is 0. Output of NAND gate is 1 when at least one of the input is 0, while the output of NOR gate is 1 only when both or all of its input are 0. Output of NOR gate is 1 only when both or all of its inputs are 0. So Along with this basic logic gate, here these are the truth table. What do we mean by a truth table? It is a table where all possible input condition of that logic gate and the corresponding output conditions were written. Remember that this entire algebra which is used for performing the logic operation, it is given by a Boolean, and as far as this Boolean algebra is concerned, it is based on some laws. Remember, whenever you have to simplify any logic circuit, you are in need of the most important law until and unless you won't have an idea of De Morgan's law. You cannot get the output, you cannot simplify the logic circuit quickly. If you are having the idea, complement of sum, look at this, complement, how to read it? Complement of sum equal to, see here, product of their complement of product equal to sum of their complement. So these two laws are very, very important, while rest of the law, commutative law, same as that of vector, associative law, same as that of vector, distributive law, same as that of vector. Now here some identities are there. In digital circuit, use the identities. See here, a plus a equal to 1. What does it mean? A is the input or it may be output. Remember, for logic gate, their inputs or output may be at logic 0 or logic 1 level. Logic 0 means 0 volt. Logic 1 means 5 volt. So a plus a equal to 1 means a can have only two possible values. Let us consider 0. 0 plus 0 equal to what? 0 means a plus a equal to a, or 1 plus 1 equal to 1. It means a plus a equal to a. So similarly you can verify a dot a equal to a. See here, 0 into 0 equal to 0, 1 into 1 equal to 1, therefore a dot a equal to a. So in this way, you see here again the most important, a double complement. If I take a as 0, complement of 0 is 1 and its complement is again 1. Means here double complement of a is equal to a, or a plus a bar equal to 1. Means if I take a as 0, then 0 plus 1 equal to 1, or if I take 1, a equal to 1, then 1 plus 0 equal to what? 1. So these are the identities. Along with these identities, here you can make use of two more identities. One is a plus ab. What is a plus ab? I can take a as common. Then what is left in bracket? 1 plus b. But what is 1 plus anything? 1 plus a is equal to what? 1. So 1 plus b equal to 1. But a into 1, what is a into 1? A into 1 is equal to a. So a plus ab equal to a. And the second and the most important, a plus a bar b is equal to a plus b. So these are some laws, that is De Morgan's laws. Along with these identities, you are now able to solve any circuit which is based on the logic gate. Now, already I have just told you that NAND gate and NOR gate, they are called universal building block. So in examination, you may have any of the question that by using NAND gate, you can construct NOR gate, OR gate, AND gate. By using NOR gate, you can construct NOT gate, AND gate, OR gate. See here, look at this. Now I want to construct NOT gate by using NAND gate. काय construct करायचं आहे मला? I want to construct NOT gate by using what? NAND gate. So to construct NOT gate, what is the Boolean equation required? Y equals to complement of A. Y equals to what? Complement of A. But I can write y equals to complement of A. It can be written as y equal to complement of A dot A, because what is A dot A? Look at this. A dot A is equal to A. Means y equal to complement of A, it is the Boolean equation for NOT gate. But that equation can be written as A dot A whole complement. And here I am having a symbol of NAND gate, where both the inputs are made common. Means I am having a NAND gate whose both the inputs are A. So what is its output? It is logical ANDing and its whole complement. So A dot A whole complement, but A dot A is A, means I will get y equals to A complement. This is the construction of NOT gate by using what? By using NAND gate. Now the second logic gate which I want to construct, it is AND gate. So y equals to A dot B. This is the Boolean equation for AND gate. But I can write A dot B, double complement. See here, double complement of A is A itself. So double complement of A dot B is nothing but A dot B. So see here what I have done. A and B are the inputs of first NAND gate. What will be the output of NAND gate? A dot B whole complement. And then I will take that whenever I am having single input NAND gate, it works as what? A NOT gate. So input to this is A dot B complement. So its output is what? Its complement. So Y becomes equal to double complement of A dot B, which is nothing but A dot B. So this is a circuit of AND gate by using what? NAND gate. Similarly, I want to construct OR gate. What is the Boolean expression for output of OR gate? A plus B. I can write A double complement equal to A, means A plus B equal to A plus B double complement. But by using De Morgan's theorem, by using what? De Morgan's theorem, apply De Morgan's theorem, I will put that complement first as it is, and in place of A plus B whole complement, what I can write? In place of A plus B whole complement, I can write here A bar dot B bar. A bar dot B bar. Now, I had input A and B. I want to complement them first. So, use single input NAND gate. It works as a NOT gate. If input is A, its output is A bar. Its input is B, its output is what? B bar, because these are working as a NOT gate or an inverter. Now, this A bar and B bar, they are given as an input to the NAND gate. What is the output of this NAND gate? It is ANDing of its two input A bar dot B bar and whole complement, and you know that A bar dot B bar whole complement is nothing but A plus B, means this is a logic circuit for OR gate by using NAND gate. Now, as far as Y equals to A XOR B is concerned, what I told you earlier, that XOR gate is called equality detector. Remember, output of XOR gate is 0 when both of its input are same. Means for 0 0 input, output is 0. For 1 1 input, output is 1. But whenever inputs are unequal, 0 1 or 1 0, then only output is 1. Now, as far as Y equals to A XOR B is concerned, remember, whenever I have to write the Boolean expression for output, see here, I will concentrate only on those input condition for which output is 1. So, here output is 1 when input is what? 0. Now, complement of 0 is what? 1. So, I will take A bar and B must be 1, means for the input condition when A is 0 and B is 1, then only output is 1. So, this is the first input condition for which output is 1. Or logically ORing, output is 1 when input A is 1 but B is 0. B is 0, that's why I will take B complement, because complement of 0 is 1. So, 1 into 1 it becomes 1, or here complement of 0 is 1, B is 1, so 1 into 1 is 1. So, whenever you have to write down the Boolean equation for any digital circuit, you simply concentrate on for what input condition its output is 1. So, you can write down if input is 0, take its complement, and if input is 1, write that input as it is, put a logical ending, and for the different sets you can go on adding the ORing operation. So, here Y equals to A XOR B, its Boolean equation is A bar dot B plus A dot B bar, means you want to realize the XOR gate by using what? Basic logic gate, that is NOT gate, AND gate, OR gate. So, how you can realize it? Look at this. The output expression for output of XOR gate is Y equals to A XOR B, or it can also be written as A bar dot B plus A dot B bar. Why it is A bar dot B plus A dot B bar? Because already we had seen that output of XOR gate is 1 when A is 0, means complement of 0 is what? 1, and B is 1. So, 1 into 1 is 1, or output of XOR gate is 1 when A is 1, write A as it is, and B is 0. So, complement of 0. So, 1 into 1 it becomes equal to what? 1. So, to realize this XOR gate, look at this. I will start with point A and B as an input. Now with the help of this NOT gate, I can find the complement of A at its output, complement of B at its output. Now to realize this, I will realize one by one. A bar dot B. For realizing A bar dot B, I need AND gate. So this is an AND gate. And what are the two inputs of that AND gate? One of the input is A bar. So this input is A bar. Other input is B. So here B. So output of AND gate is A bar dot B. The second term, it is A dot B bar, means again I will need one more AND gate. Here is another AND gate, whose one of the input is A. So I will take A from here. And the other input, it must be B bar, which is the output of this lower NOT gate. Now the inputs are A and B bar, so output is what? A dot B bar. Now both of them, they are logically OR. So for that we need one more OR gate. So the inputs of this OR gates are A bar dot B, OR means plus A dot B bar, but this is the required Boolean equation for XOR gate. Similarly, means by using NAND gate, we are able to construct NOT gate, AND gate, OR gate. And by using, similarly, by using NOR gate, one can construct NOT gate, AND gate, OR gate. Again, by making use of what? De Morgan's law. So to start or to make the NOT gate, we know what is the Boolean equation for NOT gate. For NOT gate, Y must be equal to complement of A. It is inverter. But complement of A, remember here, A can be written as A plus A. Look at this identity, A plus A equal to A. So I can write this as A plus A whole complement. But because A plus A is A, so that is equal to A complement. So you can realize this, a NOT gate whose both the inputs are 1, A and A, both the inputs are same, that is A and A. So you are having a single input NOT gate. And what is the output of this NOT gate? A plus A whole complement, A plus B whole complement. Here it is what? A plus A whole complement, because both the inputs are shorted. So single input NOR gate, it works as a NOT gate, Y equals to complement of A. Now to realize AND gate, any gate you can realize, first you write the Boolean equation for that gate. AND gate, what is its Boolean expression for output? Y equals to A dot B. Now you know double complement of A is A. So double complement of A dot B is nothing but A dot B. But by using this De Morgan's law, so look at this bracket, A dot B whole complement, A dot B whole complement, that is replaced by what? A bar plus B bar, and that upper complement will be as it is. Now you can realize it. For that you need input A. Here this is single input NOR gate. So what will be its output? Its output is A bar, because single input NOR gate, it works as a NOT gate. Here input is B, single input NOR gate, its output is what? B bar, because it works as a NOT gate. Single input NOR gate, it works as a NOT gate, so output is B bar. Now here we are having another NOR gate whose inputs are A bar and B bar. So the output will be what? A bar plus B bar whole complement, but that is nothing but A dot B. So that is equal to A dot B. So this is a circuit of AND gate. Similarly, to realize OR gate by using NOR gate, we know the expression for OR gate is Y equals to A plus B. Output expression for output of OR gate is what? A plus B. But double complement of A is A. So A plus B, its double complement will be taken. So here we are having here we are having a NOR gate whose inputs are A and B. Its output is what? A plus B whole complement. And again, to doubly negotiate it, or in order to have that second inversion, here we will use a NOT gate. So what is the function of this single input NOR gate? It will complement its input. A plus B complement, it is double complemented. So it becomes equal to simply A plus B. So Y equals to A plus B, means by using NOR gate, you can construct OR gate also. So until and unless you won't have idea regarding logic gate, be firm that you must know the truth table as well as the condition for the output of logic gate to be 1. What are those conditions? Output of NOT gate is 1 when its input is 0. Output of AND gate is 1 when both of its inputs are 1. Output of OR gate is 1 when at least one of its input is 1. Output of XOR gate is 1 when its two inputs are unequal. Output of NAND gate is 1 when at least one of its input is 0, and output of NOR gate is 1 when both of its input are 0. You remember these 6 lines, which is the basic condition for solving the different circuits. Along with this, you must remember De Morgan's law. Complement of sum equal to product of their complement, and complement of product equal to sum of their complement. And you can verify, you can write it in your notebook, these identities which are very much useful while solving the example. So let us have a screenshot of this board. So that is more useful while solving any example. It's my guarantee that you can solve any example asked, whether it is in NEET or in JEE or in CET or in any state CET examination. So take a screenshot of this board and then we will solve all the examples which were asked in different medical and CET examination. Now let us look at the examples which were asked in NEET 2016. Here you have to find out an expression for output of this circuit. Remember, until and unless you won't recognize the symbols of logic gate and the corresponding Boolean equation for output of gate, you cannot solve it. So this is OR gate. If inputs are A and B, what is the output of OR gate? A plus B. This is a symbol of what? NOT gate. Its input is B. So naturally its output is what? B bar. Then the output of this will be, this is AND gate. You can write here AND gate. So what will be its output? It is logical ANDing of its input. So that is A plus B. This is one of the input, dot of B bar. A plus B dot of B bar. And it is one of the MCQ, one of the choice given, that the output of this circuit is A plus B dot B bar. In NEET phase 2016, a simple circuit is given. This is AND gate and second one is what? NAND gate. And what is the question? That initially all the three inputs are at logic 0 level and then later on all the three inputs they are kept at logic 1 level. Then what is the corresponding output? So for this you must know that output of AND gate is, initially suppose all the three inputs are 0, output of AND gate is 0, this input is 0, and when both the input of NAND gates they are 0, then its corresponding output is what? 1. Means when all the three inputs are 0, output of this circuit is 1. Now later on, instead of logic 0, let all the three inputs they are at logic 1 level, because this is AND gate, output of AND gate is 1 when both the inputs are 1. He माहित है तुम्हाला, you know it. And this is also 1. So when the two inputs of NAND gate are 1, when both the inputs of NAND gates are 1, output is 0. Means the final answer is that initially when all the three inputs are 0, output is 1. When all the three inputs are 1 later on, then output becomes 0. So out of 4 choice, only that choice where y has value 1, 0 is the correct answer. And the entire solution, it depends on the simple definition of NAND gate and that of AND gate. Now again here in NEET 2017, very simple question. This is a symbol of NOR gate. Single input NOR gate, it works as a NOT gate. Single input NOR gate, it works as what? A NOT gate. So here A and B are the input. What is the output of NOR gate? A plus B complement. Single input NOR gate, it works as what? NOT gate means it will simply complement the input A plus B, and double complement of any variable is that variable, means this is equal to A plus B only here. And again here this is a symbol of NOT gate, so output will becomes A plus B. It is complement of input, but this is again the expression for output of NOR gate, means this entire logic circuit, it is a circuit of which logic gate? NOR logic gate. Again in NEET phase 2016, a quite simple example is given. One of the logic gate is OR gate and this is AND gate. So this is OR gate and this is AND gate. And the question is that for what input condition, 4 input conditions are given and you have to find out the output. For what input condition output of this circuit is 1. See here, output y. See here, how quickly you can answer this question. This is AND gate and the output of AND gate is a 1 only when both or all of its inputs are 1. Means for output of AND gate to be 1, this input must be 1 as well as this input must be 1. See here, this is the input C, and out of 4 values, there is only one condition for which C is 1. So irrespective of, we are not worried about what is the output of this OR gate. Output of AND gate is 1 only when C is 1, and for this input condition A0, B0, this also becomes 1, so output Y becomes 1. So whenever you have to solve such type of example, you must know what is the basic condition required for output of AND gate. Output of AND gate is 1 only when both of its inputs are 1. Means the C is one of the input and its value is 1 for only one time. So corresponding inputs are 1, 0, 1, for which the output of this circuit is 1. In Neet 2014, again simple circuit is given. These are the inverter, that is NOT gate. Inputs are A and B, so they get simply inverted or complemented. So A becomes A bar and here B becomes equal to what? B bar. And you have to identify what is the output. What will be the expression for output becomes A bar dot B bar, A bar dot A bar plus B, because this is a symbol of which gate? This is the NOR gate. And what NOR will do? It will perform. First it will OR the input A bar or B bar and its whole complement, that is NOR. But you know that A bar plus B bar, it can be replaced by what? So this is equal to, that upper complement is as it is, A bar plus B bar, A bar plus B bar, it is replaced by what? A dot B bar, and double complement of A is equal to A. So this is A dot B, but this is an expression for the logic AND gate, A and B, A and B. So this entire circuit, its output or this circuit will represent logic AND gate. Tell me, until and unless you won't have any idea regarding De Morgan's theorem, it is not easy for you to find out which gate it will represent, because it will take a lot of time. Then in Neet 2013, again they were asked, again there is a question that what is the output of this circuit. So you had given a simple circuit, both the gates are NAND gate. So input of first NAND gates are A and B. So what is its output? A dot B whole complement. NAND gate, logical ANDing with negation, A dot B complement. And here we are having single input. See here, all the inputs are shorted. So single input NAND gate, it works as an inverter or NOT gate. So here I will get A dot B complement as its input. And what is the function of NOT gate? It will complement it. So double complement. So again this becomes equal to A dot B. This becomes equal to what? A dot B. So this will also represent, or the expression for output of this circuit is what? A dot B, which is an expression for AND gate. See here, in Neet 2012, the question which is asked is same as that of the question which is asked in what? Neet phase 1 2016. OR gate, AND gate, OR gate, AND gate, and they had asked the same question that for Y equal to 1, for Y equal to 1, what is the input condition? And again the same table is given. So for Y to be 1, this Y becomes 1 until and unless both the inputs are 1. But this C is 1 only for this input condition. Means when A is 1, B is 0, C is 1, output Y is equal to 1. Means this is the input condition for which output Y it becomes equal to 1. Means the same question can be repeated after 3 or 4 years also. Again, in Neet 2012, there is a question that waveforms were given. See here, whenever we are talking about such type of wave, they are called as what? The digital wave. Square waves are digital wave because these waves can have value 0 volt potential or 5 volt potential. 0 volt potential means it represents logic 0 and 5 volt potential it represents logic 1. So here the question is that A and B, they represent the input waveform of some logic gate. So you are given a logic gate and whose inputs are A and B, and here there is an output and you will get such type of waveform at the output. So by connecting such type of waveform at the input, A and that of B, you will receive such type of waveform at the output. So see here, how you can simplify it. So 0, 0, 0, when two inputs are 0, output is 0. When first input A is 1, B is 0, output is 1. Input A is 1, B is 1, output is 1. Input A is 0, B is 1, output C is 1. So see here, as far as this gate is concerned, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 0, 1. So as far as OR gate is concerned, output of OR gate is 0 only when both the input of 0. A 0, B 0, then only output C is 0, or otherwise when A is 0, output C is A is 1, output C is 1. When input B is 1, A is 1, then output C is 1. When input A is 0, B is 1, output C is 1. So you can have, this is a logic gate. Which logic gate is there? This logic gate is OR gate. And what is the condition to identify the OR gate? That the output of OR gate will be 0 only when both the inputs are 0. So immediately from the first stage itself you can identify when A 0, B 0, output C equal to 0, it means it is an OR gate. Now we can simplify few more examples. Now see here, in Neet 2011 there is a quite simple question that identify the logic gate. This is the symbol of OR gate, this is a symbol of AND gate, this is a symbol of what? NOT gate, and this is a symbol of NAND gate. In Neet 2010, you were given some logic gate and inputs are A and B while the output of logic gate is Y. So you have to identify what is the logic gate and the waveform for input and output is given. Remember, whenever waveform is given, here it represents logic 1 and this is what? Logic 0. See here, you can make a table from the waveform A, B. When A is 1, B is 1, output Y is 0. A1, B1, output Y is 0. Whereas output remains 1 for all the remaining condition. So look at this. If you know that when both the inputs are 1 and output is 0, both the inputs are 1 and output corresponding output is 0. Which gate will have this property? NAND gate is that logic gate whose output is 0 when both of its inputs are what? Both of its inputs are 1 or high. Hence, it will represent a logic gate which is a NAND gate. So here there is no need of making a table and just wasting the time. Time is precious. So you must remember, look at this, output Y is 0 only for this input condition, whereas output Y remains 1 for rest of the three conditions. So when A is 1, B is 1, output Y is 0. So NAND gate is that logic gate whose output is 0 only when both of its inputs are 1. So in a single stroke you can find that given logic gate, it must be a NAND gate. In 2008, you have to find out what is the logic gate or the expression for output. Here the inputs are given as A and B. Which gate this is? This is a NOR gate. So it will first OR them and then whole complement. So it is the logical NORing of input A and B. This is single input NAND gate which works as a NOT gate. So it will complement the input. So double complement of A plus B which is equal to A plus B. And here again we are having a NOT gate. So the output will be A plus B complement, means again it is a NOR gate. Again it is a NOR gate. Means in the old days same questions were repeated again and again. Now as far as this question is concerned, here A and B are the two input and you have to find out which logic gate it will represent. These are the single input NAND gate which works as a NOT gate. NOT gate means they will complement their input. So A bar and this B becomes equal to what? B bar. And this is NAND gate. NAND gate will first AND the two inputs A bar dot B bar and its whole complement. Make use of De Morgan's law. A bar dot B bar. See here, this whole complement will be written as it is. A bar dot B bar means it is product of complement is equal to what? Complement of sum. So this can be replaced by, so this bracket it is replaced by A plus B whole complement. But a double complement of anything, any variable is that variable. So this is equal to A plus B. It means it will represent logic or gate. Logic or gate. Now here this is somewhat typical example in West Bengal. Most of the questions are quite typical, intelligent. See here, some logic gate is given and their inputs A and B are given while the output Y is given by this wave. Now as far as input A and B is concerned, you can imagine that these two input, they are 0, 0. When both the inputs are 0, what is the corresponding output? 1. When both the inputs are 0, corresponding output is what? 1. So when both the inputs are 0 and corresponding output is 1, see which gate will have this property? A0, B0, output is 1. It will represent which gate? NOR gate. So that logic gate, it must be a NOR gate, because in a single stroke you must remember output of NOR gate is 1 only when both or all of its inputs are 0. So that's why here this will represent A plus B whole complement, or that gate is a logic NOR gate. Logic NOR gate. Here you are given A, B and C as a 3 input, and you have to find out the expression for output Y in terms of ORing operation. So see here, A and B are input. Which gate this is? This is a NAND gate. NAND means logical ANDing and its whole complement. This is the NOT gate. It will complement the input. So C becomes equal to C bar. Now the two inputs of OR gate. This is OR gate. Means it will OR the two inputs. First input is A dot B whole complement, while second input is C bar. But according to De Morgan's theorem, A dot B whole complement, A dot B whole complement is equal to A bar plus B bar. So this becomes equal to A bar plus B bar plus that of what? C bar plus that of C bar. Now we will see some more example. Now let us look at the simple question which were asked in different CET examination. Here you have to find out an expression for output voltage. Now these two gates are logic NAND gate. So the input of first NAND gates are A and B. So what is its output? It is A dot B whole complement. And this is single input NAND gate which works as a NOT gate. So it will simply complement its input, means complement of, what is its input? A dot B. But double complement of A is equal to that A itself. So A dot B. So this will represent the logic AND gate. Now here again you are given some circuit and you have to identify what is that name of logic gate. So inputs are A and B. See here, these are the NOR gate. All the 4 logic gates shown in this circuit, they are NOR gate. And remember, single input NAND gate, it works as a NOT gate. Single input NOR gate also works as a NOT gate. So if input is A, it works as a complement. So A complement will be its output. This is single input NOR gate, its input is B, so output is what? B bar. Now this NOR gate has two input, A bar and B bar. So what this NOR gate will do? It will just OR A bar, B bar plus and its whole complement. And again here we are having single input NOR gate. So what it works as? It works as a NOT gate. So it will complement its input. So complement of input means here this is complement of. Now input is what? Complement of A bar plus B bar. See here, double complement will nullify and it is left with A bar plus B bar. These double complements they will omit. Now A bar plus B bar, A bar plus B bar, it is equal to what? A dot B whole complement. That is, sum of complement is equal to complement of their product. But we know this is an expression for which gate? This is the logical expression for output of NAND gate. So this circuit will represent a NAND gate. Now again here some circuit is given and the initial input A, B and C. Initially all the 3 inputs are 0 and later on the inputs are 1, 0 and that of what? 1. And here you have to find out a pair of output. See here, when all the 3 inputs are 0, 0, 0. Remember always for NOR gate its output is 1 only when both the inputs are 0. And C is also 0. This is a NAND gate. 1 into 0, 0 and its complement is what? 1. So output D becomes equal to 1 when all the 3 inputs are 0. When the inputs are 1 0, see here 1 0, output of NOR gate is 0, because the output of NOR gate is 1 only when both the inputs are 0. So 1 0 and this is 1. For 0 1, 0 into 1 is 0 and its complement, because this is NAND gate. NAND gate means A into B and whole complement. 0 into 1 is 0 and its complement is what? 1. So the output of this circuit will be 1 comma 1 when first all the three inputs are 0 and later on the three inputs are 1 0 and that of 1. Again, you may be given a circuit just like this one, that identify this will represent which logic gate. Already we had discussed that NOR gate can be used to represent, or NOR gate can be used to construct OR gate, NOT gate, AND gate, XOR gate. They are universal building block. So to identify what is the logic gate this circuit is representing, see here, these are the NOR gate, single input NOR gate, they works as a NOT gate. So input is A, output is A bar, input is B, output is what? B bar, and here it is a NOR gate. So output Y is equal to A bar plus B bar and its whole complement, because it is sum and whole complement. Now A bar plus B bar, A bar plus B bar is equal to A dot B by De Morgan's theorem. So whole complement, A dot B whole complement, so they will cancel and we are left with what? A dot B. So this is also going to represent AND gate. This will also going to represent what? An AND gate. A bar plus B bar is equal to A dot B whole complement. Now here you are given some circuit and you have to find out an expression for output. Inputs of, now first identify the logic gate. These two logic gates are OR gate and this is what? AND gate. Now OR gate means its inputs are A and B, output is what? A plus B. Now the input of lower OR gate, see here, A and that of C. So output is A plus C. And here this is AND gate. It will logically AND the two inputs. So Y is equal to A plus B into A plus C. A plus B into A plus C. You can even simplify it. A into A plus A into C plus A into B, or B into A plus B into C. A into A is what? A into A. A into A is A plus AC plus AB plus BC. Now what can be taken common? Here you can take A as a common. So in bracket it is 1 plus C. Plus again here you can take B as common. It is A plus C. So this is equal to, now 1 plus C or 1 plus A is equal to 1. So this is equal to A in bracket BA plus BC. Again you can take, see here, AB plus BC, A plus AB. Now what is A plus AB? A plus AB is equal to A. Means you can replace A plus AB by A. So this is A plus BC. This is equal to what? A plus BC. Now again in some exam, three logic circuits were given with their input condition and you have to find out what are the corresponding output. See here, NAND gate, NOT gate, OR gate. 1 1. What is the output of NAND gate? When both the inputs are 1, output of NAND gate is 0. 1 into 1 whole complement. 1 into 1 whole complement. 1 into 1 is 1 and complement of 1 is what? 0. Now this is NOT gate. It will complement 0 into 1. Now this is OR gate having input 1 and 0. Output of OR gate is what? 1 plus 0 means it is equal to 1. So for the input condition 1 1 0, output of this circuit is 1. Now here we are having NOT gate. NOT will complement, 0 complemented becomes 1, 1 after complementation it becomes 0. This is the NAND gate. NAND gate means logical ending and its complement. Complement of 0 is equal to 1. This is NOR gate and AND gate. NOR gate means it is 1 plus 1 whole complement. 1 plus 1 or in 1 complement of 1 is 0. 1 and 0 logical ending, output is what? 0. Quite simple. Now here you have to write down the truth table for this logic circuit. Now as far as A and B is concerned, here this is NOR gate. Output of NOR gate is what? A plus B whole complement. This is single input NOR gate, works as a NOT gate. So Y is equal to double complement of A plus B. So double complement is that variable. So this is a plus b. So what is the truth table for OR gate? Truth table for OR gate will be 0 0 0, 0 1 1, 1 0 1 and 1 1 1. So out of 4 truth table, you can select that proper truth table for logic OR gate. Now here y equal to 1 for which input condition? The question is, you are given a circuit and the question will be like this, that for what input condition output y is 1. So you can write the input a, b and that of c. A, b and that of c. So for what, see here, this is a NOR gate. What is NOR gate's function? A plus b whole complement. And this is c. So y becomes equal to a plus b complement dot of c. Dot of c. So you have to make a truth table for this logic circuit. So here in examination you are given y equal to 1 for which input condition? So a plus b whole complement, a plus b whole complement dot of c, means here a plus b whole complement means what? A bar dot of b bar dot of c. Y equals to a bar dot of b bar dot of c. Now it may be in your mind that you have to make a table for all 8 input condition and the corresponding output conditions. See here, when I wish to find out y to be 1 for which input? See here, y equal to 1 when, see here, equation is what? A bar dot b bar dot c bar. A bar means complement of 0 is what? 1 dot complement of 0 is what? 1 and c is 1. So when I take a as 0, b as 0 and c as 1, then I will get 1 into 1 into 1 equal to 1, means a 0, b 0, c 1. See here, 0 0, input of NOR gate are 0 0, output is 1, and input of AND gate, input of AND gates are 1 1, output is what? 1, means y equal to 1 for which input condition? When a is 0, b is 0 and c is 1. So the trick behind here is that whenever you will get an expression for output of any logic circuit, and if input is taken with a complement, you always take that input as a 0 in order to get the corresponding output y to be 1, in order to get the corresponding output y to be equal to 1.